Welcome back.
To school.
Yeah.
For the first section of the year, section 1.1, we're going to model. We're going to do modeling and equation solving.
Now, modeling is not like, walking the catwalk in New York City. It's a little different.
Oh, I thought you were going to talk about like a clay model.
Well, it's not that either, what Miss Parham does.
Although I would say that in some ways it is similar to a clay model.
Okay.
Because you are representing something with something else.
And you got to use your hands to mold it correctly.
Yeah.
Okay. All right, let's dive in.
In math, there's typically three ways that we model data.
Okay.
Numerically.
Yep, I like that.
Which means using tables.
Right.
Algebraically, which means using equations.
Okay.
And graphically, which means using graphs.
I like it.
So, we're going to have an example here that it's quite an example. It's pretty lengthy, and it all has to do with this data that is about the minimum hourly wage over the years. That's this first column.
So people in 1955 earned 75 cents an hour.
If they were on minimum wage, that's correct. Now, what's interesting is that they've also figured out somehow the purchasing power of what the dollar was then compared to what it would have been in 1996.
Oh,
because 75 cents in 1955 is not like 75 cents now. Like,
no.
You can't even buy a Coke hardly for 75 cents
Back then,
now.
you could get a Coke for like a nickel or something.
Yeah, exactly. So that's what this other column is for, is it's showing on kind of a more standardized line of, in 1996, this is what that amount would have been worth.
In a dollar amount that we would be more familiar with.
Right.
Yeah. Okay.
So in this example, we are going to answer some questions. So part A, in what 5-year period did the actual minimum hourly wage increase the most? MHW stands for minimum hourly wage. So when did it increase the most? Well, that requires us to look at between each of these and figure out which one of these has the biggest gap. So like these are, I can actually eyeball.
That's 25 cents.
25, 25, 35.
35, yep.
50. But here's a dollar.
A buck. A whole buck.
So, and then, and you might make notes on this to help you keep track. That looks pretty good right there, that dollar increase. 25
cents. What is that, 45 cents maybe?
Yeah, 45.
45 again.
45 again. Now, this is 90 cents.
Oh, that's close.
That's close, but, and then this is 0.
Oh, it didn't change.
So, from 1975 to 1980 would be the period where it increased the most. And so we just had to check how much did it increase each time and then pick the biggest one.
You're finding the difference. So difference is subtraction, right?
Right.
Okay. And
what year did a worker earning the minimum hourly wage enjoyed the greatest purchasing power?
So in other words, when we're looking in those $1996, I want the most bang for my buck.
Right.
Right.
So even though this column continues to go up and up and up, this one actually goes up and then comes back down.
Yeah, fluctuates.
Kind of fluctuates down here. So 647 is the biggest number in this column. So in 1970,
biggest one that I see.
That's whenever you had the most purchasing power.
Right. Okay.
So back in the day. Okay, part C. A worker on a minimum wage in 1980 was earning nearly twice as much as a worker on a minimum wage in 1970, and yet there was great pressure to raise the minimum wage again. Why would this be?
Well, I would think that the purchasing power would have the biggest impact on that. It's like the minimum wage discussions that are going on today.
Yes.
So you want what you have to go as far as possible.
Right. If you look at 1970, you're at $1.60. In 1980, it's at $3.10. But how much it's actually worth is $6.47 versus $5.90. That's about a 50-cent difference. So I would say inflation had to do with that.
Yeah, or something like that, yeah.
So how do we want to say that?
So, why was there pressure? Because in 1980, the $3.10 would not buy as much as the 1970 $1.60.
That's really well put. I wonder if I can remember all that. In 1980, the $3.10
would not purchase
as much
as the 1970 $1.60.
And
Now, you
like
can
said,
reword this a little bit
Yeah.
as well, but this is going to take a complete thought to actually answer this question. It
Right.
can't be because 1980 happened.
yeah,
Like-
or because more.
Right.
You know, like that doesn't make any sense. Like whenever you see the word why, a lot of times you need a complete sentence.
Right.
Because typically complete sentences mean complete thoughts,
Correct.
kind of, in general.
All right.
So now we'll have to go to the next set of subpoints here. You'll still be able to see all this because you've written it down, but we're going to go right here. We're going to model the data graphically with two scatter plots on the same graph so that you can see.
I'll
the
just type
points
these
there.
in real quick.
We're going to do it two ways. We're going to do it on our paper. You have a graph provided there. We're also going to show you, and a calculator should pop up here on the side. We're going to show you how to make a scatter plot in your calculator as well. So if you need to rewatch this section more than once,
Building a scatter
Go for
plot
it.
is pretty handy on your calculator. It helps in more ways than you even know right now, but it's a good skill.
right. Now, one thing that we do a lot of times with scatter plots when we have years is, notice here it says measure time in years since 1955. So that means that instead of starting out with 1955 here at the bottom on my time scale, I'm actually going to start with 0. And then my years are going up by 5s. What am I going to
Stop at 50.
stop at 50? And then we have a range of numbers as far as our dollar amounts that we have to pretty much be almost from 0 up to about $7. So I
Yep.
think I made this graph to where you could go up by 50 cents on each mark. So
Just need to
here
go.
would be,
Which one are we doing?
$1.
Purchasing power.
we're going to end up doing both.
Okay, so you need to go, up to about $7.
Okay, so each line is 50 cents, so I just labeled every other line. And then you would go through and you'd preferably have like two different colors or maybe a pen and a pencil, and then you'd be able to mark out points for minimum hourly wage. When you're on your calculator and you're doing this, there's a way to set it up to where there's two different kinds of marks going on.
Right.
So on 1955, we're at, which is at 0 years, we're at 0.75. So that's right there. And then 5 years later, we're at $1. And then we're at $1.25. Then we're at $1.60.
210, 310, high
Ooh.
cotton, 335, 380,
Oh no, hang on. 335.
335, 380, 425, and 515 twice.
And our book is kind of old, so we actually know that in 2010, I don't know when it actually went up, but right now isn't it higher than 515?
I believe so, and I believe they're talking about maybe raising it again.
Yeah, they've talked about it again for that same reason we mentioned of the purchasing power. All right, so that's one color, and you can see that this looks pretty linear.
Yep, pretty straight.
And we could say that there's a correlation
Yes.
because of how straight that is, and it's
Right.
a positive correlation.
And it's a pretty strong
because it's going up.
correlation because all the data is pretty close together.
Right. All right, so on the other one, 439, and then 530,
623, 647, 612, 590, 488, 456, 438, 469, and 415.
So this is much less linear.
Much
Not
less
really-
correlated.
yeah.
It's more loose.
And so, whereas with the first set of data, because we've looked at it like this, we can see there's definitely a connection in the years gone by and the minimum wage. You cannot say the same thing about years gone by and how much that money
Right, because
is
we
worth.
actually started off.
Pretty good.
Well, we're now
Well,
earning less than we started in 1955.
Yeah,
So
that's true.
right.
So we're on party. We're going to model the data algebraically with linear equations of the form y equals mx plus b. You write one equation for each set of data. Use the 1955 and 2000 ordered pairs to compute the slopes. Are these equations good models of the data? So in 1955, for our minimum hourly wage, I guess I should have switched back to blue for that. Our minimum hourly wage, if we use the 1955 data point, that's 0,0.75. And then the 2000 one would be, that's 45 years after we started when we are making 515. Now, why would we pick these two data points? Because if we look on our graph, that's this point and this point, and if we drew a line between there, that'd be a decent
It's pretty
line.
straight.
So,
I accidentally
did you find it?
I did a regression on the whole thing.
And that's good. We'll see how close that is.
Okay, sounds like a good plan.
But before we do that, in order to get a line from this, we need to use point slope form,
Right.
and we need to use that slope equation.
Yeah, the one, stop
Yeah.
minus start sort of thing.
Yeah, m equals y2 minus y1 over x2 minus x1.
Right.
So 515 minus 75 cents
It's going to be 440,
over 45.
which is 0.0977 repeating.
Okay, so that's
your slope.
0.098.
Yep.
And the great thing, though, about this, if we use this point and point slope, which is y minus y1 equals slope times x minus x1. Since x1 is 0, all we really have to do is just add that
slide
over.
that guy over. So we would need 0.098 times 0.75.
No, we don't.
Well, if you...
We just have
No,
to...
you don't. No, you don't. I was just kidding.
You were just kidding.
I was
That
just
was
checking.
a good joke.
I
So
was
this
just-
is our line of best fit we came up with. You can use your calculator, though.
And let me get back to it.
And so it all has to do with, we showed you, as this video went along, we showed you how to put these data points in your calculator, and then you type in, or you go to the menu and do linear regression.
Right.
And it gave us...
0.968, which is 0.97, which is really close.
Pretty close.
But the y-intercept was different. It was 0.443 instead of 0.75. So it's a pretty close.
Yeah.
It just happens to work that way on this collection of data. It doesn't necessarily always work that well when you take that first point and an end point.
Right. And now if we do the same thing with our green data here, which is the purchasing power, and we use the first data point, which is
0.439.
and the
2000 would be 469. I don't feel like that's going to be a very good representation.
I don't feel like it is either. Our slope, we do 469 minus 439 over 45 minus 0.
So it's 0.3 divided by 45, and that is 0.006 repeating.
0.006 repeating. Okay. And then if we want to be smart, we can already know actually that this is the y-intercept.
Yeah, do that guy.
Y equals
And I'll do a complete regression here.
0.0067x plus 4.39.
Wow. It doesn't match at all.
It doesn't match at all.
Not even close.
But either way, it wouldn't have been a very good representation. No. This is the line that we just found. Like, does that at all represent this data well?
No.
No, not at all.
And the linear regression, which I would argue that that's not even the best way to look at this data.
No, probably a different kind of function.
Yeah, I would say so. This linear regression gives us the equation y equals negative 0.026x plus 5.84.
Wow, so that's
so
very
they had
different.
A negative slope and everything. So it's not the same.
So the end question, are these equations good models of the data? I would say that the first one is.
Yes, the blue equation, definitely a very good representation.
But the
green one is it's terrible.
And so last, if the minimum wage continues to follow the linear model found in E, what will the minimum wage be in the year 2015? Now, this is just around the corner from us. Actually, it's 2014.
We can see if it's going to line up.
And so we would take this model right here.
Yeah, we'll use that one and not the one I found on my calculator.
And we're just going to put, how many years is it from 1955 to 2015?
That's 60,
That's
right?
60 years. So that's what goes in for X. You would not want to put 2015 in for that.
No, don't do that.
And you just figure out what this is.
$5.96.
$5.96.
Which I think minimum wage is actually $7 or something like that.
I thought it was, I don't know.
I don't either.
We don't make minimum wage.
We don't. We make less than that, so.
Well, that's a whole other story.
So,
let's not get into that.
All right.
But the whole point is that because we had data that followed kind of a linear fashion, that allows us to try to predict what might happen in the future.
Make a good prediction.
Yes, and
Not
that's
some crazy
one of the
prediction.
cool things about mathematical modeling.
Indeed. All right.